Okay, so as you can probably tell from the title of this video, this is about the limits of composite functions. So these can be a little tricky. Sometimes they come out really nicely and sometimes they don't. And I'll show you both cases. So first off, we'll look at these like nice continuous functions. And if we are to find the limit of a composite function, so like the limit as x approaches c of f of g of x, this is typically equal to f of the limit as x approaches c of g of x. Now sometimes this is a little weird, and I'll show you why, but typically this is how this works. So let's say we were looking for the limit of x approaches 3 of g of f of x. This would be equal to g, maybe I should make this here. This would be equal to g of the limit as x approaches 3 of f of x. And the limit of as x approaches 3 of f of x, well, from the left it's going to 2, and from the right it's also going to 2. So this is just equal to g of 2, which is 6. And in this case, this worked. But it won't always work. Like if we look at these functions, and oh boy, look at f of x in this case, there are quite a few discontinuities. It's not all continuous. The functions aren't always going to work. So first, let's look at maybe the limit as x approaches 4 of g of f of x. Well, using the little property that I put up earlier, this is g of the limit as x approaches 4 of f of x. But if you notice, as x approaches 4, the left side of f of x is going into positive infinity, whereas the right side is going to negative infinity. And this limit doesn't exist, and we can't take g of like infinity, really, of a value that doesn't exist for our limit. So this right here does not exist. However, what if, let's do one more example, and I need to add another point here for this one. I love this color, by the way, it's so pretty. Let's say, what about, I should probably add an x coordinate for that. This will be at 7. What about the limit as x approaches 7 of f of g of x? So this is equivalent to f of the limit as x approaches 7 of g of x, which is equal to f of what is g of x as x approaches 7. That's f of 4. But f of 4, again, the limit here does not exist because it's unbounded. From the left side, it goes up into positive infinity, whereas on the right side, it goes down into negative infinity. So this limit also does not exist. All right, so do you think that it is possible for you to have, in a composite function, one part of the limit that doesn't exist while the whole composite function limit exists? You might think, like, looking at these examples, like, no, that can't happen. Both of these parts, both the internal function and the external function, they both have to exist. But, that's not the case, considering the fact that I'm still sitting here asking this question, talking about it. So let's talk about how these functions can exist if one part doesn't exist. So what about the example of the limit as x approaches 3 of f of g of x? So for this one, this is f of the limit as x approaches 3 of g of x. So as x approaches 3, from the left, g of x approaches 9, and from the right, it also approaches 9. So this is just f of 9. However, there is no limit at f of 9. And so you might think, well, if there's no limit, if it's just f of 9, then the answer is going to be 8. But, so you might think if this is f of 9, that's just going to be 8. But no, it's still a limit. But it's not really f of 9, it's the limit as x approaches 3 of g of x, which is approaching 9, but approaching 9 from values less than 9, because as you can see, this value, it's approaching from underneath 9, it's going up. This is also approaching from underneath 9, it's going up. It would be different if it went like this, but it doesn't. All the values are coming from underneath 9. So it's not really f of 9. It's kind of more like f of x as x approaches 9 from values less than 9, so from the left. And so that's why when we're solving for this limit, it's really going to be more like this, meaning that the value is going to approach whatever 9 is here, it's going to approach from the left. It's going to be a one-sided limit from the left, meaning it's going to be equal to 6. All right, so that's when the external limit does not exist, but the overall composite limit does exist. Now let's talk about when the internal limit does not exist, but the total composite limit does exist. So this, for example, would be, where would it be? Okay, let's try the limit as x approaches 9. Sorry, I keep using these same numbers. I was too lazy to draw like 8 different graphs or 4 different problems, so I'm just using the same graph with different numbers. Let's do the limit as x approaches 9 of f of g of x. No, the g of f of x. And so the limit, let me make this a little smaller so I can write, I have more space to write. The limit, move up, this freaking board won't move up. Okay, the limit as, this is equal to g of the limit as x approaches 9 of f of x. Well, this is a little weird because this limit right here does not exist. But it's not that it doesn't exist because it's unbounded, like right here at x equals 4. It's that it doesn't exist because there's a jump discontinuity. So from the left side, the left-sided limit is equal to 6. So if we were to look at this from the left side, it would be g of 6. But, and this is as x approaches 9 from the left. But if we were to look at this from the right side, so where x approaches 9 from the right, well, this is approaching 8. So this entire thing is equal to 8, and in this case, this is g of 8. But if you look right here on g of x, well, g of 6 is equal to g of 8. They're both the same thing. Both of these are equal to 6. So since the left-sided limit and the right-sided limit, yeah, sure, they would produce different things in the internal function, but once you plug them into the external function, they produce the same result. So in this case, the limit also does exist, even though our first internal function, this f of x, the limit here at 9, did not exist.